SQL Server lets you use any of three types of encryption keys. An encryption key is the small piece of data that, when plugged into an encryption algorithm, converts the data into gibberish that is virtually impossible to convert back into the unencrypted text without the proper decryption key. The first type is an asymmetric key. This kind of key uses a public-private matched key pair. One key encrypts the data, and the other decrypts it. You can share the public key with anyone so that any data they encrypt, only you can decrypt by using the private key. SQL Server uses the Rivest, Shamir, Edelman RSA encryption algorithms in 512, 1024, and 2048-bit keys, some very strong encryption. Another type of key is a symmetric key. In this kind of encryption, the key that encrypts and decrypts the data is the same. This is sometimes called a shared secret, because both parties who share data have to have the same key. In some scenarios, it's difficult to use symmetric keys because securely transmitting the secret from one party to the other is a problem. Symmetric keys, though, are ideal for use within a database because they never leave the database. SQL Server supports RC4 and RC2 algorithms, as well as the DES, DES, and AES families of algorithms. But one note about RC4. Microsoft has wisely deprecated RC4's symmetric key encryption in SQL Server 2012, and it's only supported when the server's compatibility level is set to 90 or 100, which corresponds to SQL Server 2005 or 2008 for backward compatibility. Turns out RC4 has a number of vulnerabilities. Amongst them, the algorithm wasn't salting the key, so that encrypting a value repeatedly resulted in the same encrypted text. This makes breaking the encryption far easier than it should be. So even if you're maintaining compatibility with older versions of SQL Server, don't use RC4. And then, the third kind of encryption key is a certificate. A certificate is really just a digital wrapper for a public key as part of your asymmetric key encryption. SQL Server can create certificates for your use, or you can get one from a third-party certificate authority. SQL Server uses the Internet Engineering Task Force X.509 specification for its certificates. The nice thing about that is that it's widely used, so you'll be able to exchange certificates with other software applications. SQL Server uses an encryption key hierarchy. It uses the hierarchy in order to encrypt and protect keys that you store within the database. At the server level, each instance of SQL Server has a service master key that you use to encrypt other keys that are lower in the hierarchy. This key is created when you install the SQL Server instance. You can back up and restore that service master key, as well as regenerate it if it's ever compromised. For the most part, you'll leave it alone. SQL Server manages for you, and you'll never have to explicitly use it. The service master key is stored and protected deep within Windows itself, using the Windows Data Protection API, or DPAPI. And then the service master key is used in turn to protect the database master key, which is required in any databases that you are going to use encryption within. And then you can use that database master key to protect certificates, asymmetric keys, and then you can create symmetric keys that are in turn protected by either certificates or asymmetric keys, or by another symmetric key, as indicated by that little looping back arrow in the lower left part of the image. For all of these keys within the database, you can also protect the keys using a password. And I'll talk a little bit more about taking responsibility for protecting the keys yourself. Here's the code that I'm going to use to show you how encryption works within SQL Server 2012. First thing I need to do is do a little bit of setup. I'm going to create a few logins and then create a database called Encryption DB, because I'm going to need to create a table in order to store encrypted data. So I'll go ahead and create that database and use it. Okay, then I'm also going to create a few users because encryption keys are objects within the database and they need to be owned by somebody. All right, so now I want to talk about the service master key. So first of all, I'll go back to master. The service master key has some internal uses, but for our purposes here, SQL Server uses it to encrypt and protect any database master keys that you create. And again, a database master key is required in any database in which you encrypt data. Keep in mind that you don't have to create the service master key. It's automatically created when you install an instance of SQL Server. There are a few maintenance tasks that you can perform. For example, one of the things that you should do, certainly on production servers, is to back up the service master key. And you can use code like this. So you back up the service master key to a file, whatever location where you want to put it, and then you want to protect that with a strong password. Because SQL Server will encrypt that data within that file, and only someone with the password can realistically retrieve that service master key. And then, if disaster occurs, you can always come back and restore that service master key. Now, this could be an important step because keep in mind that this is the key that is going to be used to encrypt the database master key. If you lose the service master key or it becomes corrupted or something happens, then you won't be able to decrypt and access the database master key, which means that you may not be able to retrieve the other keys within the database, which means that you won't be able to retrieve the encrypted data within the database. Okay, so disaster ever occurs, you can use the restore service master key from file in order to restore it from the backup. But you have to have the backup in order to